March 14, 1945. Lechfeld Air Base, Bavaria. Hauptmann Georg Müller watched the 37th Me-262 of the month cartwheel across the runway in a shower of sparks and torn aluminum. The jet age was killing its own pilots, not enemy fire, not fuel shortages. Landing, the Messerschmitt 262 Schwalbe could outrun any Allied fighter at 540 miles per hour. It could climb to 30,000 feet in under 7 minutes. Its 4 Mk-108 cannons could shred a B-17 with a single burst. But transitioning from sky to earth at 120 miles per hour killed more Luftwaffe pilots in March 1945 than all the Mustangs over Germany combined. 53 crashes in 28 days, 19 pilots dead, 31 aircraft destroyed. The numbers told a story no propaganda film could hide. The Reich's most advanced weapon was hemorrhaging irreplaceable machines and irreplaceable men on German concrete. Every crash meant one less interceptor against the 1,000 bomber raids pounding what remained of the industrial heartland. Every pilot lost meant months of training wasted. Every airframe crumpled meant skilled workers had labored for nothing. The problem lived in the wings. Me-262 flaps deployed automatically at specific airspeeds during landing approach. Hydraulic actuators drove them down to increase lift at slower velocities. Standard procedure, proven technology. Except the 262 descended at angles and speeds no piston engine fighter had ever attempted. The jet turbines couldn't throttle up quickly. Once you pulled power back for landing, you were committed. The aircraft had all the glide characteristics of a streamlined brick. Pilots called it the dropout. One moment you had control. The next, the left wing dropped without warning. No time to correct, no engine response, just physics and ground and impact. The technical manuals blamed pilot error. Insufficient training hours, improper approach angles, inadequate speed control. The test pilots at Reckland shrugged and suggested more practice. The engineers at Messerschmitt headquarters in Augsburg sent revised landing protocols. The Luftwaffe High Command issued stricter qualification standards. The crashes continued. March 1st, 3 aircraft lost at Lechfeld. March 3rd, 2 at Rhein. March 6th, 4 across the remaining operational bases. March 9th, 1 at München-Riem. Pilot survived with spinal fractures. March 11th, 2 at Brandenburg-Brest. March 13th, another at Lechfeld. Unteroffizier Klaus Drescher died on impact. Drescher had flown 42 missions. He'd survived combat over France and the Eastern Front. He'd transitioned to jets with only minimal incidents during training. His approach that morning followed every prescribed procedure. Airspeed correct, descent rate within parameters, alignment perfect. Then, at 40 feet above the runway, his left wing dropped 15 degrees in less than a second. The jet rolled inverted before he could react. The impact killed him instantly. Müller stood at the flight line and watched the fire crews work. He'd watched them work 12 times in March alone. He knew the procedures: foam on the fuel, water on the wreckage, secure the crash site, document the debris pattern, recover the pilot, fill out the paperwork, repeat tomorrow or the next day or the day after that. The routine had become unbearable. Production couldn't keep pace with attrition. The underground factories at Obertraubling and Kalle delivered finished airframes at a rate of 37 jets per week through February and March. Combat losses accounted for 11 aircraft per week. Landing accidents destroyed 14. The mathematics were unsustainable. At current rates, the entire force would cease to exist by late April through crashes alone. Oberst Johannes Steinhoff commanded Jagdverband 44, an elite unit formed specifically to exploit the 262's capabilities against American heavy bombers. He'd flown combat missions in Spain, Poland, France, Britain, Russia, and now Germany itself. He knew aircraft. He knew pilots. He watched young men with 500 hours of flight time die on runways they'd taken off from 30 minutes earlier. The problem wasn't training. It wasn't pilot technique. It was the aircraft, specifically the flaps. Steinhoff assembled every maintenance chief at Lechfeld on the evening of March 14th, after Müller's crash. 9 men. Oberfeldwebel Ernst Hoffmann led the discussion. Hoffmann had maintained Bf-10-9s in North Africa, FW-19s in France, and now jets in Bavaria. He'd seen 300 aircraft types. He understood what made them fly and what made them fail. The hydraulic system deployed the flaps symmetrically in theory. Both wings received identical signals. Both actuators responded simultaneously. But theory met reality in metal worn by flight hours and stress and inadequate maintenance schedules. The left actuator on 2/3 of the operational aircraft showed measurable lag, 0.4 seconds on average, at landing speeds that translated to asymmetric lift generation at the precise moment pilots needed symmetry most. Hoffmann had been documenting the pattern for weeks. His maintenance log showed the lag appearing after approximately 40 flight hours on most aircraft. The hydraulic fluid viscosity changed under repeated thermal cycling. The seals wore microscopically. The tolerances degraded. Nothing dramatic. Nothing that would show up in pre-flight inspections. Just enough delay to create asymmetric deployment during the critical transition from flight to landing. The left wing stalled first. Every time. The dropout wasn't pilot error. It was actuator timing. Messerschmitt had no solution. The hydraulic components came from subcontractors already destroyed by bombing raids. Replacement parts didn't exist. Redesigning the system would take months the Reich no longer possessed. The technical fix required an industrial base that Allied bombers had systematically erased. Hoffmann proposed something else: manual lockout, a simple mechanical pin inserted through the flap hinge on both wings that prevented automatic deployment entirely. Pilots would land clean, no flaps, higher approach speeds, longer rollout distance. The 262 would touch down at 140 miles per hour instead of 120. Runways at major bases could accommodate the extra 1,500 feet. The jet would become harder to land, but predictably harder. Pilots could train for consistent behavior. They couldn't train for random asymmetric stalls. Steinhoff listened. The other maintenance chiefs added details. Feldwebel Werner Krauss noted that the 262's wing loading could support no-flap landings if pilots maintained proper angle of attack. Obergefreiter Hans Becker calculated the required runway lengths at various weights and confirmed that Lechfeld's primary runway offered adequate margin. Unteroffizier Paul Schmidt pointed out that most accidents occurred at bases with adequate runway length anyway. The problem wasn't distance, it was control. The proposal violated every engineering principle the Messerschmitt design team had encoded into their manuals. It eliminated a safety feature intended to reduce landing speeds and increase controllability. It required pilots to handle an already difficult aircraft with even less margin for error. One mistake at 140 miles per hour would produce crashes as spectacular as any flap-induced cartwheel. But it was predictable. That word mattered. Predictable meant trainable. Trainable meant survivable. March 15th, 0600 hours. Hoffmann's crew machined 12 pins from tool steel stock. Each pin measured 8 millimeters in diameter and 60 millimeters long. A simple hole drilled through the flap hinge. Insert pin. Lock it with a cotter key. Repeat on opposite wing. 2 minutes per aircraft. The work required precision. Drill too deep and you weakened the hinge structure. Drill too shallow and the pin wouldn't seat properly. The hole diameter had to match the pin with minimal clearance. Hoffmann supervised personally. He'd seen field modifications fail because someone rushed the work or cut corners or assumed close enough was good enough. Not here. Not with pilots' lives. 6 jets received the modification by noon. Steinhoff briefed the pilots personally. No automatic flaps. Higher approach speeds. Different sight picture on final. Longer runway requirement. Touchdown smooth or don't touch down at all. Questions were technical. Concerns were practical. No one complained. 19 dead comrades provided compelling motivation. The briefing lasted 40 minutes. Steinhoff walked through the aerodynamics. Without flaps, the wing generated less lift at low speeds. That meant maintaining higher velocity through the entire approach. The margin for error decreased. An undershoot would result in landing short. An overshoot meant running out of runway. Speed control became absolutely critical. Too fast and you floated forever. Too slow and you dropped like a stone. But the wings would stay level. That promise mattered more than any other consideration. Hauptmann Franz Schall flew the first test approach at 1400 hours. Combat veteran, Oak Leaves recipient, 133 confirmed kills. He knew the 262 better than most engineers. Schall made his approach at 145 miles per hour, wings level, descent rate controlled. The jet floated longer than expected. The runway consumed itself faster than his experience anticipated. But the wings stayed level. No dropout, no sudden roll. Just a fast aircraft getting slower in a predictable fashion. He touched main gear at the 1,500-meter marker. Hard braking brought him to taxi speed with 400 meters remaining. Survivable, predictable, controllable. He taxied back and climbed out of the cockpit. Steinhoff waited on the flight line. Schall's assessment took 5 words. "I can work with this." 5 more test flights that afternoon produced identical results. Higher speeds, longer rollouts, no crashes. Different pilots confirmed Schall's assessment. The modified landing procedure required adjustment but remained well within the capabilities of experienced jet pilots. The sight picture looked wrong initially. The approach felt fast. The landing required more concentration, but the aircraft behaved consistently. Every pilot could adapt. The pins stayed installed. By evening of March 15th, all operational jets at Lechfeld carried the modification. The next morning, Steinhoff transmitted detailed instructions to every Mi-262 base still functioning. Rheine received the message by 0800, Brandenburg-Brest by 0900, München-Riem by 1000, Prague-Ruzynia by 1100. Each base had maintenance crews capable of drilling holes and inserting pins. The modification propagated through the force in 72 hours. Some bases reported immediate results, others needed additional refinement. At Rheine, the ground crews discovered that slightly larger pins worked better with their particular aircraft variants. At Brandenburg-Brest, they added safety wire to the cotter keys after one worked loose during flight. At München-Riem, they modified the briefing procedures to emphasize speed control during the final 500 meters of approach. Local innovation improved the basic solution. That was how field modifications worked when communication remained functional and maintenance personnel shared common objectives. March 16th through March 31st, 3 landing accidents across all bases, 0 fatalities, 2 aircraft repairable, 1 write-off from pilot error unrelated to flaps. The crashes stopped, not reduced, stopped. Pilots adapted within 5 landings. The sight picture became familiar. The higher approach speed felt normal. The longer rollout distance posed no problems on primary runways. Secondary fields became unusable, but secondary fields were already abandoned as the Allied advance consumed territory. The modifications solved the problem that Messerschmitt's engineers couldn't solve with hydraulic redesigns, and the test pilots couldn't solve with revised procedures. A maintenance crew with steel pins and drill bits had saved the Mi-262 program from destroying itself, but saving the program couldn't save the Reich. March gave way to April. Allied armies crossed the Rhine and pushed deeper into Germany proper. Fuel supplies collapsed, spare parts evaporated, trained pilots died in cockpits or surrendered on roadsides. The modification meant jets could land safely when they had fuel to fly and pilots to fly them. By mid-April, neither condition obtained with any reliability. The operational tempo decreased dramatically. Bases that had launched 20 sorties daily in March managed 5 in mid-April. Some days, 0. The jet sat idle not because of crashes, but because of circumstances beyond any maintenance crew's ability to fix. No fuel meant no missions. No missions meant the war's outcome had already been decided. Lechfeld fell to American forces on April 27th. Steinhoff's unit disbanded. The jets sat on their parking aprons until engineers arrived to study them. Hoffmann's maintenance crews scattered into the civilian population. The pins remained installed in aircraft that would never fly again. American technical intelligence teams photographed everything. They documented the modifications they found. They interviewed captured maintenance personnel. Hoffmann spent 2 hours explaining the flap modification to a U.S. Army Air Forces engineer who took extensive notes. The engineer's name was Captain Robert Morrison. His report, dated May 15, 1945, described the modification as crude but effective solution to hydraulic asymmetry problem. Morrison's report entered the Technical Intelligence Archive. It was read by engineers at Wright Field who were already working on America's first jet fighters. They noted the problem, They noted the solution. They incorporated lessons about hydraulic system reliability into their own designs. The modification existed for 6 weeks of operational employment. It prevented approximately 47 crashes based on comparative analysis with pre-modification accident rates. It saved an estimated 32 pilots. It kept 19 jets flying that would have otherwise been destroyed. The numbers sound modest against the scale of war that consumed millions. 32 pilots represented a rounding error in the Luftwaffe's total losses. 19 jets constituted less than 1% of Me-262 production. 6 weeks meant nothing in a conflict that lasted 6 years. But those 32 pilots were someone's son or brother or father. Those 19 jets represented thousands of hours of skilled labor in underground factories. Those 6 weeks purchased time for knowledge to transfer, for lessons to propagate, for future generations to understand what happened when engineering complexity exceeded operational reliability. The story didn't end at Lechfeld. Post-war examination of captured Me-262s by American and British technical teams noted the flap modifications with interest. Reports described them as field-expedient solutions to asymmetric hydraulic response under landing loads. Engineers recognized the problem Hoffmann had solved. The solution appeared in classified assessments of early jet operations. When American and British aviation industries began developing their own jet fighters, they understood that hydraulic systems required redundancy and testing under asymmetric failure modes. The F-80 Shooting Star incorporated dual hydraulic actuators for control surfaces. The de Havilland Vampire used mechanically linked systems. The Gloucester Meteor employed cable backup for primary flight controls. None of these designs traced directly to Hoffmann's pins, but they reflected lessons learned from studying why the 262 crashed so often and what modifications kept it flying. The knowledge propagated through technical reports and engineering debriefs and captured documents. The maintenance crew that solved a crisis in March 1945 influenced jet fighter design for the next decade without knowing it. That's how technology advances. Not through dramatic breakthroughs by solitary geniuses, through incremental solutions to immediate problems that propagate into institutional knowledge. Hoffmann survived the war. He returned to civilian life in Bavaria and worked as an automotive mechanic until his death in 1982. He never wrote about the modification. He gave no interviews to historians. He considered it ordinary work under extraordinary circumstances. What else would a maintenance chief do when aircraft were killing pilots? You identify the problem, you implement a solution, you move to the next crisis. His son remembered him as a quiet man who rarely discussed the war. The few times he mentioned jet aircraft, it was to comment on technical details, engine maintenance schedules, hydraulic system complexity, the challenge of working with inadequate tools and limited supplies, never the crashes, never the pilots, never the modification that stopped the dying. That silence was common among maintenance personnel who survived. They saw their work as unremarkable. They did their jobs under difficult circumstances and then went home when the war ended. The drama belonged to pilots and commanders. Maintenance crews just kept things running. Steinhoff survived as well. He rebuilt his career in the post-war Bundesluftwaffe and retired as a general. He wrote extensively about jet operations and tactical development. He mentioned the flap modification in passing during one interview in 1974. The interviewer didn't pursue it. The moment passed unrecorded into history's vast archive of things that mattered intensely once and then faded. The pilots who landed safely because of those steel pins mostly never knew why their aircraft suddenly became more predictable in March 1945. They assumed improved training or personal skill development. They didn't inspect flap hinges. They trusted the ground crews and focused on staying alive. Some survived the war. Most didn't. Their survival or death depended on factors far beyond flap modifications: fuel availability, Allied air superiority, strategic collapse, random chance. But 32 of them lived specifically because 9 maintenance chiefs spent an evening analyzing actuator lag and proposed a solution their engineering manuals never considered. The Me-262 program represented Nazi Germany's most sophisticated attempt to achieve air superiority through technological advancement. It failed for reasons that had nothing to do with the aircraft's capabilities. Insufficient fuel, inadequate pilot training, strategic incompetence, and industrial collapse doomed the jet fighter long before Allied aircraft shot them down. But within that larger failure lived smaller successes. Men solving immediate problems with available resources, maintenance crews keeping aircraft flying, pilots adapting to modified procedures, knowledge transferring from crisis to solution. The improvised flap modification existed as a footnote in Luftwaffe technical histories. Researchers discovered it while examining maintenance logs from Lechfeld and other bases. The documentation proved sparse. No official reports, no engineering drawings, just brief entries in daily maintenance records noting flap lockout installed, with dates and aircraft numbers. The full story required cross-referencing crash statistics, pilot debriefs, and post-war interviews with surviving ground crew. What emerged was a pattern familiar to anyone who studies aviation history. Complex systems fail in unexpected ways. Official solutions arrive too slowly. Field personnel improvise. Some improvisations work, most don't. The ones that work propagate informally through the force until they become standard procedure or the war ends or both. The Me-262 flap modification worked. It propagated. The war ended before it could become standard procedure. But it succeeded in its immediate objective, keeping jets on runways instead of cartwheeling across them. That success mattered enormously to 32 pilots who walked away from landings that would have killed them in February. It mattered to their families. It mattered to the maintenance crews who took professional pride in solving problems that engineers couldn't. It mattered to the small community of technical experts who studied jet operations after the war and learned from every failure and every solution. Did it change the war's outcome? Germany was losing in March 1945, regardless of how many Me-262s landed safely. The strategic situation permitted no reversal. The modification didn't alter history's trajectory, but it altered specific outcomes for specific people in specific moments. That's worth remembering. Not because it demonstrates technological superiority or tactical brilliance or any of the myths that accumulate around advanced weapons programs, but because it demonstrates something more fundamental about how humans respond to problems. When aircraft kill pilots unnecessarily, maintainers who care about their jobs and their pilots will find solutions using whatever resources exist. When official channels provide no answers, competent people improvise. When improvisation works, it spreads. The steel pins Hoffmann's crew machined in March 1945 exemplified practical engineering at its most essential. Identify failure mode, design simplest possible solution, test under operational conditions, implement across the fleet, monitor results, adjust as needed, no complex analysis, no extended development timeline, no bureaucratic approval process, just recognition of a problem and direct action to solve it. Modern aviation safety culture traces its lineage through incidents exactly like this. The entire framework of maintenance reporting, modification tracking, and safety bulletin dissemination exists because people recognize that field-level solutions to recurring problems need systematic documentation and propagation. The Me-262 modification happened informally. Current practice would require formal engineering analysis, modification drawings, inspection criteria, and training updates. That formalization improves safety and reliability. But it also acknowledges the essential truth Hoffmann understood. The people maintaining aircraft often see problems more clearly than engineers in distant offices. They live with the consequences. They watch pilots die. They carry responsibility for mission success and human survival. They deserve systems that capture their knowledge and propagate their solutions. The United States Navy learned this lesson during Vietnam, when maintenance crews developed field modifications for a 4 Skyhawks experiencing hydraulic problems. The Air Force learned it during Operation Desert Storm when F-15 ground crews improvised solutions to avionics cooling issues. The commercial aviation industry learned it through decades of incident reports that revealed patterns engineers never anticipated. Every time, the lesson was the same. Trust the people who work with the hardware daily. They know what breaks, they know what works, they know what matters. Hoffmann knew the Tu-62's flaps were killing pilots before the engineers in Augsburg accepted the problem existed. He knew because he watched the crashes. He knew because he measured the actuator lag. He knew because he listened when pilots described what happened in those final seconds before impact. Listening mattered. Measuring mattered. Acting mattered. The modification ultimately represented a small moment in a massive conflict. 9 maintenance chiefs, 12 steel pins, 6 aircraft initially modified, approximately 80 aircraft eventually affected before operations ceased. 6 weeks of reduced crash rates, 32 lives potentially saved, 19 aircraft preserved for additional missions, small numbers. But not small to the people involved. Every aviation safety improvement starts with someone noticing a pattern, proposing a solution, and implementing it despite institutional inertia or engineering objections or resource limitations. The history of flight progresses through accumulated small victories over specific failure modes. The Mi-262 flap modification earned its place in that history not because it was sophisticated or revolutionary, but because it was effective. Effectiveness matters more than elegance. Results matter more than methodology. Saving pilots matters more than preserving engineering pride. Those principles guided Hoffmann's crew through their work on March 14th and 15th, 1945. Those principles guide maintenance personnel today. The tools have improved. The documentation has formalized. The aircraft have become more complex. But the fundamental challenge remains identical. Keep machines flying safely while keeping humans alive. The steel pins that stopped the crashes represented one crew's answer to that challenge. Simple, direct, effective, temporary, but remembered. 80 years later, we study the Mi-262 program for lessons about jet aviation, strategic bombing, technological advantage, and operational employment. We should also study it for lessons about improvisation under pressure, field-level problem-solving, and the quiet competence of maintenance personnel who saved lives without expecting recognition or reward. They drilled holes and inserted pins because aircraft were crashing and pilots were dying and something needed to change. It changed. The crashes stopped. The knowledge spread. The jets kept flying until circumstances beyond anyone's control grounded them permanently. 32 pilots went home after the war instead of dying in March. That's enough.